working? Perfect. So my name is Nicolas. This is John.
My name is John.
And you can see your Twitter account. We are easily reachable. We both work at Google on Android Studio and on the ConstraintLayout library. So we're going to talk today about ConstraintLayout 2, but because it's actually a large amount of stuff that we have in ConstraintLayout 2, today we are mostly going to focus on MotionLayout. And just to quickly review a little bit what we have in ConstraintLayout 2, of course, we have some layout stuff, like in ConstraintLayout 1, and we have a little more functionalities there. We have some helper objects. If you know ConstraintLayout 1, think about the guidelines and stuff like that. We have a few more facilities like that that will make your life easier. We have some new rendering tools with decorators that will let you create much nicer UI, hopefully. Some library size, if you're trying to use complex UI or desktop-like environment like Chromebooks, we provide API for that as well. The bulk of ConstraintLayout, or the new stuff, and in some way that's the thing that we are more interested with, because all of the previous things are interesting, but I don't think they are that complex to understand. MotionLayout is a big part of ConstraintLayout 2 that introduces a lot of new ideas, a lot of new concepts, or a twist on existing concepts. So that's mostly what we're going to focus on this talk. A little bit of API as well, some of the new API we introduced. But that's going to be the bulk of the talk. And just, if you don't know about it, we actually released the Alpha 1 of ConstraintLayout 2 just 3 weeks ago.
So, MotionLayout. The first thing we want to talk about with MotionLayout is sort of why we're doing it and what is it all about. Well, first to know it's a subclass of ConstraintLayout, so that there's nothing that you did in ConstraintLayout that you can't do with MotionLayout. And it builds heavily on the philosophy and the design style of MotionLayout. But we felt that animation is sort of part of UI, and we want to be able to give the users a powerful UI toolkit that provides the animation capabilities. We hope to encourage regular UI developers to think about building animation as part of their UI development tasks. As such, we're trying to make it as deep as possible so you don't run into a brick wall somewhere down the line. We have about 8 different APIs in animation in Android. And one of the things I dislike about it is do it with this or do it with that, and kind of, you have to jump into Java and do this piece. So we're building a lot of stuff into this thing so that you will not run out of steam. But on the flip side, don't feel like the first thing you have to do is learn all of MotionLayout before you actually go build something in it. It's designed to have more depth than you need. So let's scope it a little bit. We have 4 basic areas of animation we can talk about. Animated content, and we talk about Lottie and a bunch of other toolkits, or animated vector drawables, or just GIFs. But below that, you have Transition Manager. You have something that moves views around for some purpose. Another kind of similar thing is Coordinator Layout. And even lower than that is Property Animators, sort of moving things around. Our goal is to try and take care of all of the bottom 3, to be that it could be a one-stop shop for that, or it can work with them if needed.
And just to be clear as well, even though we don't specifically want to provide like a solution for the animated vector drawable space with MotionLayout, we obviously can use such libraries in MotionLayout, and you can easily control the progress of an object like that within MotionLayout, for instance.
The other big thing about it is it's declarative. And one of the things to realize is right now in Alpha 1, we're only putting out the XML fundamentally. We have a few minimal set of APIs. We hope to stabilize the XML first before we start making a rich content in API land. But we do plan to put it out with API eventually. Very important for being declarative is that we can tool it. And if you saw the demo we did at Google I/O, essentially we are building a tool for using this. In Studio, it's coming. When, we're not sure. But we're working on it. And having a very declarative format where we own all the layers going down means that we can mathematically know exactly what the system is going to do because we can read the XML and we know what it does. And so that we can then turn around and display to the user paths on the screen. This is where it's going to go, this is what the object is going to do, that kind of thing. So it's very important for us to be declarative. No?
Okay, so in terms of what is it that MotionLayout, what are the concepts, I guess, that MotionLayout exposed to you? The four main ones, and the last one is more like a combination of how to use the first three together. The first one is transition. It's like, you want to transition from one type of UI, one layout, to a different version of that UI. So it's kind of, you want to move stuff around, maybe change their properties, and you want to interpolate all of that. There is some events management as well that we'll cover, and some more advanced, like a more advanced topic with keyframes, and we'll cover keyframes a little. So for transition, the general idea, if you played the ConstraintLayout one, we had this object called ConstraintSet, and the ConstraintSet encapsulate all the layout rules. So what's nice with it is that you can have more than one constraint set, and then you can apply the constraint set to your layout, which means that you can hold multiple versions of your layout and toggle between them. And if you use that in conjunction with Transition Manager, those transitions will automatically be moved, and the layout will nicely morph into the new version of the layout. So that's really nice, but we were not satisfied with it. And one of the reasons we were not satisfied with it is that it was not seekable. What do we mean by that? It's simply that with Transition Manager, once you start, you can't really stop that transition. You start, the transition happens, and that's it. So you cannot move or go at a specific point in time in between those two states. The reason why is because Transition Manager, like often in computer graphics, is lying to you. When you say, go there, it already went there. And in fact, backtrack and just move the objects in reverse so that you think that you're transitioning, but in fact, you're already done. The other issue with that is that because you're already done, you cannot really easily go back and forth between the things. So on its own, why not? It's not a huge problem, it's just one limitation. But if you look at more modern UI, and you can think about coordinator layout is a good example with this kind of interactions, you want something where the user would be the person driving the interaction. So with touch, for instance, and you can decide when you will do the transition, how far you're going to that transition, etc., etc. So MotionLayout provides such a system, and the general architecture is that we use constraint set, we keep that idea of the constraint set, and we just interpolate between two constraint sets. So here is a very basic example. I have two states. I have a beautiful view on the left. I wanted to move it on the right. How do you do that with MotionLayout? Well, it's a subclass of ConstraintLayout. So you just create your layout. You just replace ConstraintLayout by MotionLayout, and that's it. You have the view. I call it button, with background color, some size. The interesting thing here is that there is no constraint, because in fact we point to a separate file, and all the constraints, all the rules for your layout are going to be put into that external file. That external file motion scene contains a bunch of information. Typically, you will have an element called transition that will specify, okay, what is that transition? You can actually have more than one transition, and the transition will specify the start and end constraint set, the duration, and there's more attributes as well. And there we go. And you can see the constraint set here. I can declare it directly into the same file. So before with constraint layout, you were declaring all your rules into that layout file. Now you can move that into that motion scene file, and you can have more than one. So you can have this version, which will give you those type of rules. My widget will be centered vertically and aligned to the left. And I can also have the end constraint set, which, it's not rocket science either. It does the same, but aligned to the right. So now that we have those two constraint sets, we can just use it in the file, and that's all. That's really all you need to do. So it's very similar to what you are doing with constraint layout. Now, okay, we've set up this thing. How do we actually transition? How do we, say, okay, go do it? Well, you could, easily add a button. I'm going to call it run. Add some click listener and tell MotionLayout, yeah, go to the end. So go to the next transition, to the next state in this transition. And that's all you need to do. You click on run, and the element will move. Another thing you could do to basically do exactly the same stuff, you can add an on-click handler that's going to say, by the way, if you click on the run stuff, that's going to transition as well. Similarly, instead of an on-click, you can use an on-swipe, and that's kind of nice because then, you can simply use your finger to drive the transition, to drive the progress of that transition. You may be able to see the touch. I like this kind of white circle, which is great with a white background to see. There's a couple of attributes you can use right now. As John said, we're working on a UI builder or like a motion layout editor, that is graphical, all integrated in Studio, but it's not ready yet. So in the meantime, you can use a couple of attributes to help you when you develop with motion layout. The one I would specially highlight is show path. That's going to show you all the different paths that your objects are going to take during the transition. And you also have progress that goes from 0 to 1 that will set, that will let you see where, at any point in time during the transition, what the layout looks like. And that was today in Studio. So what are the things we do support in motion layout in terms of, okay, we have those two states, we interpolate. So we do the typical things that we were doing before with constraint layout, like the position, the dimension of your widgets. We also deal with visibility, the alpha channel. We do support a few more things, like the translation, rotation, scale, elevation, etc. But the more interesting thing is that we now support custom attributes. If you did play with animation and transition like that in Constraint Layout 1, you are limited to the set of layout attributes. Essentially, the only thing you can transition easily like that is the basic position and dimension of your widgets, where they're going to end up on screen. The problem is, when you want to do any animation that is a little more complex than that, for example, you want to change the background color of your widget, you cannot do it with just the layout attributes. So with custom attributes, you can specify very easily, okay, I'm going to, for that first state, I'm going to have my background to be red, and for that other state, the background will be blue, etc., etc. So here is how we do it in XML. You only have to create a custom attribute, indicate its name, and the color value, and that should be all. We did a couple of utilities in the library that should come in handy. So one that I kind of like is mock view. So mock view, it's when you are basically building your UI, but you're not quite sure exactly what's going to go there. In that panel, you just know you have a panel and you want to make sure the animation or the interaction goes well. You can just use a mock view instead of a normal view. You'll have the cross diagonals. You can set up a label. It's kind of useful. But the one I really love is image filter view. Image filter view is a simple subclass of image view that does support some command operation on images. So you can set up the saturation, the contrast, etc. And here is a quick example. So if I do it a little slower, let's do it slower, you'll see that what we do a crossfade between the two images. If you ever played with this kind of effect, it's actually surprisingly hard to do with Android. So, you know, we thought that this kind of utilities would be helpful. And so to do it, it's very easy. You just, in your XML, you declare Android source and Android alt source in that case, with two images. And in the motion scene, the only thing really that you have to think about is this custom attribute. So in the start state, I'm setting it to 0, and in the end state, I'm setting it to 1. So it's really rocket science, but I think that should be manageable. We have a few API in transition in the MotionLayout object itself that lets you specify where you want to go. Transition to end, transition to start. For the current transition, you can transition to a specific state. You can have more than 2 states in a motion scene. You can also set the progress. We've been trying to be pretty conservative for now, at least for the Alpha 1, in terms of the API surface that we expose. There is definitely a lot more we are thinking of and a lot more that we will do. But we wanted to first focus on kind of like the concept and see what the feedback we get from you guys, right? Okay.
Events. Essentially, we as part of the API, we have a few things that you have to make this thing work. It's just things that are going to be needed. The first thing is you want to be able to listen to that transition as it's happening, because you might have your own code that you're driving based on it for some other reason. And that's a simple interface callback. You implement this interface and you add it, and it's pretty obvious. It'll tell you the motion layout that it's in, what's it going from and to, and what's its progress along that path. And it will try and keep a fairly consistent life cycle. Things like the start maybe -1, because you could, in theory, be transitioning from an unknown state. And that's a little bit more of an advanced subject, and we won't be discussing any more than that on it. One of the big things that we wanted, and you just saw him do, is on-swipe. And on-swipe is a system we've spent a lot of time trying to design to allow you to get those smooth interactive motions when you're swiping from the left or the right and interacting. And it's a little bit complicated and a little bit subtle, so we'll go through it kind of in detail so that you get it the first time and you don't get confused. So the first thing we have to realize is that you're going to add this on swipe, as Nicholas showed. And it's going to control the position. There are 3 attributes that it has in it at its minimum: the drag direction, the touch anchor ID, and the touch anchor side. The drag direction is the intent of the swipe. Are you expecting the user to be swiping up, or are they swiping from the left or the right? The anchor ID is the object in the animation that you want to act as if you're moving. And the side is what side of that object you're going to act on. And this becomes fairly important, as you'll see. So the first thing to know is it's not going to create an animation for you. It's actually just going to drive your animation. It's going to be calling your set progress on this animation based on its understanding of what the animation does. So you will see, if you said the anchor side is the top, in this particular animation, that's my finger touching it. Even if I touch anywhere, it tries to track the motion of my finger with the top side of this view. And similarly, if I do it on the right, and I set swipe right, it will track the right side of that view. Now, this will And you see, you can do it on the bottom. And in the bottom, it might seem a little bit awkward for this particular animation because the bottom doesn't move as much because the top is what's moving a lot. And so it might look and act funny in this particular case. And if you get it completely wrong, it'll mess up. Because this side of this object goes backwards. It goes forward this way, and then it moves back out. And so the differential of that curve with respect to this direction goes negative, and it's going to cause it to flip. So you have to choose the side that you anchor to carefully. Now, one of the big things we added is what happens when your finger goes up. What we do is we calculate the velocity that you're moving at when your finger goes up, and we pick a curve based on reaching to zero, to the position with zero velocity, so that the motion will always be smooth and continuous. And you see in this thing, it always produces a smooth and continuous movement. So OnSwipe also has some other parameters which we won't get into to tune whether you want it to accelerate faster or do you want it to have a higher maximum velocity, that kind of thing. So another API, which is very simple, is the onClick API. And that's an easy one. It's just, you add it to any view or button, and it'll listen for a click on that button and drive the animation. So it's a simple way to test, to drive the whole system if you want to. And it has some modes where you can say, I want it to toggle. You can also have it actually just jump directly to a particular state. So skip the animation part, just go to that state. Okay, the keyframes is, now everything we showed you so far, we were able to accomplish, or most of what we showed you so far, we were able to accomplish without keyframes. And in fact, we feel that for many animations that are needed, you won't even need to deal with the concept of keyframes. But in keeping with the need for depth, when you actually need to control the system in detail, you're gonna need to have keyframes. And so we're gonna get into a lot of the little details of keyframe animation. So essentially, the way to think of keyframes is it's gonna specify a point in time and some piece of behavior or place, something that has to be at that point in time. The time is not real time because it's your finger's motion across a set progress, and from the point of view of the keyframes, they go from 0 to 100, and you can have 101 keyframes, essentially. Keyframes, as of Alpha 1, has only 3 different types available: key positions, key attributes, and key cycles. But more are coming. So key position, the first one we'll talk about is position. This is kind of the simplest one in some sense, but it has a lot of subtlety. So if you do a normal animation as you saw before, it's going to have a starting and an ending constraint set. In this case, the constraint set made it smaller and bigger. But by adding a keyframe, you distort the motion. So in this particular case, at halfway through the position, this widget, so we have motion target, which is the widget, the keyframe position, which is where on that 0 to 100 scale, which is halfway, and we want to have %x as 1.2. And that brings up a subject of coordinates, but we'll cover the coordinate systems in a little bit. But we can add others. So another thing we might want to do is control the size. So keyframe position is all about controlling the system as layout sees it. It will control, when layout is called on this object, the positions of those values will be determined by keyframe position. In this case here, I've decided to delay the changing of the size till it hits this point. So you see it keeps its size and then it expands. So you can control a size very easily like that. We might also want to just lower the object a little bit, so we lower the start at point so more time, more velocity is provided in the second half of that motion. So this sort of digresses into the coordinate system you're just seeing. And in fact, we have 3 coordinate systems. The first one, if we think about a view, a parent, which is a motion layout, and we have a widget, it's going to occur at 2 points in time. And our coordinate systems are going to be relative to what's going on with that object. So the first coordinate system that we'll talk about is the simplest, which is called parent relative. And essentially, the coordinate system has its x going from 0 to 100 on the size of the image, on the size of the layout that is underneath. It's good for when you have big, giant motions that are relative to the frame, so going to the top left-hand corner, things like that. But in a lot of cases, you're going in small motions, and remember, the 2 points can change based on the animation involved. So in this particular delta relative, we actually now have the scope of the coordinate system goes 0 to 1 is the x of x is the x coordinates transform, and 0 to 1 of the y is the y coordinates transform. And now we have a third one, which is a little bit strange for people, where we actually rotate the coordinate frame to the path, where along the path is the x of the coordinate system, and perpendicular to the path is the y coordinate system. So these can go negative as well as positive to get it. Now, remember the paths will change because the path is determined by layout, which is determined by the font and the text on the font and the size of the phone and all the other parameters that affect layout. But this way you can produce paths that are relative to the system. So let's go into attributes now. So,
and one thing for the coordinate system is that it's actually per keyframe. So you could have different coordinate system, on each one of your keyframes if you want.
Yeah, so you can achieve very complex motions, and we'll at a later date we will probably show more and more complex, and some of our examples have a few complex keyframe stuff. So let's talk about attributes. Now, attributes are key attributes, and you can set any of what are the post layout attributes that are standard on views. Nicholas mentioned a few of them before. And in this particular case, I just set the rotation so it doesn't show up as a dot on this line, but at a quarter way along the path, I actually had it rotate 45 degrees. Now, what it did was say, I saw that it was 0 at the start, it's 100 it's 0 at the end, and it'll go at 45, and it does an interpolation and an interpolation back of the rotation. So you get a smooth interaction with that rotation. Now, you might not like it because you said, I don't like it sideways right here. I want it to line up and go vertical at that point. So you can just add another keyframe where you have the rotation at 50, go back to 0. So the interaction will then rotate 45 degrees during this first part of the animation, and then go back to 0. So you can control very detailed. Now, there are a lot of attributes, including custom attributes. So you can do this with any custom attribute as well as colors and the width and height and anything like that in the system. So this brings the last of what we have now in Alpha 1, cycles. And as we go through these, we get into what I consider rarer and rarer use cases of motion layout. Cycles allow you to produce oscillations in the system. One of the challenges of building a keyframe type animation is that if you want to have swooping curvy motions, you have to put a lot of keyframes in to get those motions. And it just becomes too difficult to do it that way. You burn a lot of time. a lot of cycles. So in this particular case, I'm adding a kind of a weird wavy motion, very simply, with a few keyframes. And we'll get into how that works, but you can kind of see the path now has this weird jiggling, and in fact, what I'm affecting in here is the translation X of the post layout. Now, any attribute that you did with key attributes can also be done as a key cycle. And so, in some sense, key cycles are a superset of key attributes. Now, the way the cycles work is there are two parts. The value, so you'd set the rotation of or the translate X, and it would sort of act as a waveform shaping of the wave. And that's kind of easy to sort of conceptualize. It's sort of like the gain on a signal. The period is a little bit weird and a little bit hard to wrap your head around when it's slow. But the way to think about it is we try to create that many waves as the number of periods that you add. So if you count there's a total of 9 periods. And if you count the number of peaks, you'll see there are 9 peaks in here. So what it's trying to do is produce a smooth, continuous curve. What it does is produce a smooth, continuous curve with this many oscillations in it. And when it says 2, it's going to try and produce 2 waveforms between this 0 and this 0. And in the other one, it's going to try and produce 7 waveforms between those 2 zeros. So it allows you to, it has a very subtle control, but it allows you to control oscillations in very complex ways. You can also, it doesn't have to be a sine wave. We support about 7 different waveforms. I won't deal with the waveforms here. So now that you kind of understand that, you see that we're adjusting at a particular position. We need a certain wave period and a certain translation of some object. So some of the numbers there seem to be wrong from my reading. Okay. So now Nicholas will sort of put it together in some more real-world examples.
Okay. So yeah. So we talked about a lot of essentially the conceptual framework that MotionLayout gives you. And as you saw with cycles, it can get pretty tailored. So you don't, first of all, don't freak out. You don't have to use all of them. It's like design patterns. Don't use all of them. Same thing. The one thing that's important with MotionLayout to realize is that it's not like an all or nothing world. You can start integrating MotionLayout in your project with your existing architecture, your existing layouts. So let me cover a few examples. So let's talk first. So we'll cover a little bit with coordinator layout, drawer layout, view pager, and finally a final example tying everything together. The general idea is that we're using the progress attribute of MotionLayout. So any MotionLayout has this progress attribute, and that goes from 0 to 1, and you can set it. It can also be done intrinsically when the system runs, but otherwise, you as the developer can set the progress specifically. So we can use that to do interesting things. For example, if I want to replace the collapsible toolbar of app-bar layout in coordinator layout, and I want to replace that with MotionLayout because, well, MotionLayout allows me to do a lot of what you typically do in a lot simpler way and in a declarative manner. So here's a basic example, right? I have this header, and I want that header to, change the background, the image in the background color, and the text would be rotated. So to do that with app-bar layouts would be not fun if you tried. Specifically, you would have to do a lot of code. So instead what we can do, we'll do a little bit of code. We'll create a small subclass of MotionLayout that is only to basically pass the offset of the app-bar layout and set that as the progress of my animation. That's all. And you can take this class, put it in your project, and use it. That's all you have to do. And all it does is, essentially, is it takes that, the amount of progress on the bar layout, on the coordinator layout movement, and translate it into a progress for motion layout. So the steps are very easy. You just replace the collapsing toolbar layout by a motion layout. That's all. So that's your typical structure, with a coordinator layout, the bar layout, etc. Then you have to create a layout for this header. Relatively easy. We are using our subclass, and here are you just using an image view, and we have a text view. That's all. And finally, we have to create a motion seed to specify what type of motion and transition we want. So this is what it looks like. We just specify the transition from start to end. Here it's very easy. We have only 2 states. And I won't go into details, but you get the idea, right? You specify the different rules to get those 2 things. And that's all. Then you plug all of that together, and now this header is expressed with motion layout. So that's one way where you can start using motion layout now. You don't have to reinvent the world and transform everything into motion layout, which we can. You can simply just, piece by piece, add some interesting motion into your UI. So here is another example with drawer layout. So I kind of like drawer layout personally, but what I don't like, and it's a little bit what I don't like with coordinator layout, is that all the applications tend to be exactly the same. And they tend to be exactly the same because actually, building a custom version of those is hard. You have to go into code. There's a lot of, corner cases. So what people end up doing is, well, they just use the default stuff, which makes me sad. So we can use, a drawer layout that is a little more interesting with motion layout. And the way we can use that is really simple as well. You use drawer layout as usual. It's just that instead of using, for example, a frame layout, you would use a motion layout as the content of the drawer layout. So if you do that, same thing, you have to transform somehow to translate the motion of the drawer layout into the progress of motion layout. And we are going to use the same trick as what we did for coordinator layout and the toolbar. And here it's even simpler because they actually provide us, a slide offset that's from 0 to 1, so we can simply say my progress is that, and that works. We can continue with this approach with ViewPager. So if I want, something like that, same thing. I can simply divide that progress from 0 to 1 and says I'm going to move at those particular things. Similarly, you'll just look at the on-page call. Here I'm just hard coding the number of tabs you have in your ViewPager, but you get the general idea. So that shows you that you can use motion layout today. It's not like you have to forget everything that you know about the existing system on Android. You can just test the water a little bit before going full in. And full in, that's what we're going to do now. So that's actually personally what I'm the most excited about with motion layout, is that we are trying to provide you a system that is very expressive, something that is not going to contain you in those specific buckets that some engineers in Mountain View wrote at some point. So I'm not going to do something different just for the sake of it, but let's try to replicate a coordinator layout behavior. How would you do that with motion layout? Well, we can split the problem in 2. One, we want a header that's going to go from the state in the left to the state in the right. We already did that, I showed you, right? So that does show something, though. It shows that we can use a motion layout inside a motion layout and drive the progress of that nested motion layout by the outer motion layout. So let's say that's our child motion layout for the header. For the outer motion layout, the root motion layout, we only need to specify those 2 states. And you will notice that in the first state, my header is big. Second state, the header is small. And in the second state, I'm also adding a fab, because why not? The rules are actually very, very straightforward here. You know, that's essentially what you end up with. I'm going to simply change the dimension of the header, and I'm going to, you know, toggle the visibility of the fab. And how it looks, really straightforward. I'm just using includes here because that's not super important, but I got my header, that's going to be this motion layout. I have some random, you know, scroll view for the content, and my floating icon button. The motion scene that we use is very, you know, very straightforward as well. I'm using an on swipe to say, by the way, when I'm going to anchor to the bottom of the header, if I remember, and that's about it. So we just, you know, set up the start constraint, and we should see, I don't remember if yeah. So that's, you know, the start constraint are basically going to give you that state. And we'll set up, similarly, the constraint for the second state. So one thing here, you notice that I can directly write motion : progress with 1, and that will automatically drive by calling the inner motion layout for the header, by calling the set progress setter. And that's really it. You know, the rest is really straightforward. I'm just saying, oh, by the way, my fab is visible. And we end up with this. And the final animation that you saw earlier is just that. So what's nice to me is that we are purely replicating what you've seen before with coordinator layout, but I think we did it in a simpler way, in a more easily understandable way, hopefully, and also in a way that really does not, you know, stick you in that particular pattern. You know, you could do whatever you want. You are just moving things around. You essentially can consider motion layout as a big choreographer for your screen and do what you want. A few documentation, there's the online documentation, the Java doc, that's accessible on developerandroid.com. We're trying to, you know, regularly update it. We also published a few articles on Medium detailing a lot of that. And in fact, all that I showed you today, it's available in large part in those articles, but also in a GitHub repository. So if you want to simply go to the GitHub repository and play with the example on your phone, because I think a very nice thing with motion layout is kind of like the tactile feedback that you get when you play with the app. So I really encourage you to just go, install the app, play with it, play with the examples. There is a lot that we have not covered in this talk. We're already at 43 minutes in, so you may understand why. But there is, you know, we are working, for example, on fragments transition and things like that. So there is way more coming. I mean, we just released the Alpha 1 3 weeks ago.
One more thing I would say about the examples. One of the big differences between this and a lot of things that you've looked at before is that 90% of it is in 2 XML files. You know, each of these layouts, each of these interactions is just an XML file that says, here's what my constraints are, here's my interactions. And so it's very easy to read it, actually, to read the XML and say, oh, it's setting this here. Once you start to understand the pattern of it, it becomes easier. You don't have to hop back and forth with a piece of Java code and how is it interacting and what's the IDs, and it's a little simpler to look at. And that self-contained will hopefully in the future give us the ability to take an example from you. You just send us the XML and say, oh, okay, this is what you all did, because I don't need the rest of your code. It's all in the XML. And we're going to try and push more and more to be, you'll be able to do everything you need to do with it in the XML. But we will actually add Java APIs because there are cases we can never cover, right? So okay.
The last thing I'd like to point is that even though it's ConstraintLayout 2 Alpha 1, it's Alpha 1 simply because we may still evolve the APIs, we may add more attributes, remove some, rename them, etc. The code actually is perfectly fine. In fact, all of the ConstraintLayout parts it's using the 1.1.2 version. In fact, right now it's even a bit faster than 1.1.2. And what we'll do is We'll probably release a 1.2 version of ConstraintLayout with the latest improvements and optimization we're working on the layout part, so that you can still have a ConstraintLayout 1 that you can use in your app if you are just concerned with layout, and we'll continue to evolve the rest of the system in ConstraintLayout 2, mostly focused on motion. That's it. Again, we are very easy to reach. Don't hesitate, we are here for that. We want to hear from you, and yeah, please give it a try.